Today's office environment is changing rapidly due to the spread of mobile devices and cloud environments. Copy machines are now expected to provide a new office output environment by improving workflow, increasing productivity, and saving energy. Within this environment, digital composite copy machines are the basis for optimal service, which offers solutions to customer business issues. Multifunction copy machines with outstanding performance. What mechanism is used to create copies? Using a basic machine, let's take a closer look at the process of creating copies. Now, let's examine the copy process in order, focusing mainly on the drum. The copy process is performed inside a black box which completely shuts out light. To understand the black box, let's start by showing the properties of the OPC drum. The OPC drum consists of a cylindrical aluminum drum which is coated with organic semiconductors made from sensitive material. The OPC drum is the heart of a copy machine. The OPC possesses interesting properties. When the surface is charged with electricity, it retains the electric charge in the dark. When exposed to light, the electric charge is removed. This is why the inside of the black box must be dark. The OPC drum plays a central role in the copying process. The charging electrode is the first component to affect the drum as it rotates in darkness. High voltage of minus direct current is applied to the electrode, which emits a corona discharge. The corona discharge ionizes the molecules in the air, thus charging the entire drum surface with minus electricity. The next process involves reading and writing of the original image. When the original image is exposed to light, the black areas absorb light and the white areas reflect light. The reflected light is conveyed to the CCD through a mirror and lens. Next, the image information for the original is converted from an optical signal into an electrical signal. These procedures are performed by the reading unit. The CCD, an essential element of a copy machine, is a device which accurately reads light. In pixel units of only a few micrometers, the CCD reads image information from the original and transfers the information into an electrical signal. The red image data, undergoing various forms of image processing, is transformed into a laser and is irradiated on the drum surfaces. These procedures are performed by the image writing unit. This is a semiconductor laser which emits laser optics. The laser possesses outstanding rapid response and enables the digital composite photocopiers to write high-accuracy images through laser spots in micrometer units. The laser is a single wavelength light which has sharp directivity. Normally, a laser with a 780 nanometer wavelength is widely used. The semiconductor laser begins to emit a laser at the same time as the original image data is sent from the image processing unit. The laser reflected by the polygon mirror is sent to the drum surface through the lens and mirror. The drum surface is operated through rotation of the mirror. The laser flashes repeatedly at a rapid speed, and image information of the original is sequentially written on the drum surface. When the laser is irradiated on the drum surface, the electrical charge is removed only at irradiated areas. Through this operation, a charged image which is invisible to the human eye, an electrostatic latent image, is formed on the drum surface. Now, let's try an experiment. What will happen when we apply negatively charged toner to a drum with a charged image? As you can see, text is clearly visible. Toner adheres to areas where the charge has been removed. This adherence of toner is actually performed by the developing unit. A developing roller is installed inside the developing unit. The surface of the roller is similar to fine sand. This toner has been uniformly adhered by the carrier, which is a magnetic material in a cylindrical sleeve. When viewed with an electron microscope, you can see an infinite amount of toner has adhered around the carrier. The adhered toner has an extremely small size of only a few micrometers. The toner is negatively charged due to friction with the carrier caused by rotation of the sleeve. In the developing process, toner inside of the developing device is adhered on the drum surface. This is the development process seen from inside the drum. Text appears when toner adheres to areas where the electrical charge has been removed. In this way, a toner image is created which is visible to the human eye. In synchronization with the start of image formation on the drum, copy paper is sent from the feed tray with perfect timing. At the paper feed unit, several rollers with different functions work skillfully together to send single sheets of paper to the drum surface. Furthermore, the control board conducts precise control of paper feed speed and timing in order to ensure a perfect match for the paper edge and the edge of the image formed on the drum. The next process involves transferring toner on the drum surface to the copy paper. Copy paper passes between the transfer roller and the drum with the formed toner image. At this time, the transfer roller attracts drum toner to the copy paper by emitting a positive from behind the copy paper. The next process is separation and voltage removal. Here, using the curved surfaces of the drum and roller, copy paper is separated from the drum surface. At the same time, a minus high voltage is discharged to remove electrical charge remaining on the copy paper. Now that separation and voltage removal has been completed, let's take a close look at copy paper immediately after output. Toner adhering to the paper surface seems to be floating in small round particles. As a result, the toner smears easily when touched by an object or the hands of the user. The next process fuses toner to the copy paper. In the fusing unit, copy paper which has been separated from the drum passes through high-temperature thermal rollers. The heat and pressure of the roller causes toner on the copy paper to melt and fuse to the paper. Toner is fused to the copy paper and the surface is now flat. The toner will not smear even when touched by an object or the hands of the user. The final step is to remove the electrostatic charge from copy paper before it is ejected. Now, let's take a look at the drum. Next comes the cleaning process, which removes the small amount of toner remaining on the drum's surface after separation of the copy paper. This is the cleaning process as seen from the front of the drum. The blade touches the drum surface and scrapes off toner remaining on the drum. As shown here, toner scraped off by the blade is returned to the developing unit by a recycle screw which is installed inside the cleaning unit. The deposited toner is reused or collected in the waste toner box. The final process surrounding the drum involves the eraser lamp, which fulfills the role of a pre-exposure charge. When viewing the drum surface after cleaning, you can see that the electrical charge still remains. The eraser lamp completely removes the remaining charge by irradiating the entire drum surface with light. Now that the drum has been thoroughly cleaned, it returns to the process starting from charging. Charging. Reading, writing. Developing. Transferring. Separation and voltage removal. Fusing. And cleaning. These processes are skillfully coordinated in a short time that the drum makes a single round. In this way, beautiful copies are created. Until now, we have examined principles for monochrome copies using only black color. How are color copies made? To understand these principles, let's start by discussing color. Color can be divided into the RGB color model and CMY color model. Let's start by looking at the RGB color model. The RGB color model consists of three colors: red, green, and blue. By combining these three colors, it is possible to create all colors which exist in the natural world. Let's try actually combining the colors. Mixing red and green light produces yellow. Mixing green and blue creates cyan. Mixing blue and red makes magenta. Mixing all three colors, red, green, and blue, creates white. PC monitors and television screens produce images by using this principle and adjusting brightness. Now, how does a photocopier express color? Color toner, ink, and other material is used when expressing color at a photocopier. Although light becomes brighter when colors are mixed, toner and ink become darker when colors are mixed. Copy machines use the CMY color model, which consists of cyan, magenta, and yellow. Let's try actually combining the colors. Mixing yellow and magenta produces red. Mixing yellow and cyan creates green. Mixing magenta and cyan makes blue. Mixing all three colors, cyan, magenta, and yellow, creates black. Color images are expressed on paper during printing by combining the three primary colors of cyan, magenta, and yellow, as well as black, in order to adjust darkness. When using a microscope to view the ink and toner of color printing, you can see that they are composed from four colors: the three primary colors of cyan, magenta, and yellow, and the additional color of black. When creating color copies, a variety of colors are expressed by combining toner in the four colors of cyan, magenta, yellow, and black. Now, let's look at the actual method used to combine toner and create color copies. A major difference between monochrome photocopiers and color photocopiers is the developing process. There are several types of developing methods used by color machines. Here we will examine principles using the tandem method, in which developing units are placed side by side. In the tandem method, there are individual drum units for each color of cyan, magenta, yellow, and black. Exposure and development is performed separately for each color. When the original is scanned, the original image is divided into four colors. After image processing, the yellow image is the first to be created on the drum surface. The image creation principle is the same as for monochrome. After the yellow image has been created on the drum surface, the yellow toner image is transferred to a belt called the transfer belt. Next, the magenta image is created on the drum surface. Then the magenta toner image is transferred to the belt on top of the yellow image. The same process is performed in the order of cyan and black. Toner images are created on the drum surface, and the original image for four colors is transferred to the belt with exacting precision. Afterwards, the image on the belt is transferred to the copy paper, and fusing is performed. In this way, beautiful, high-definition color copies are created. constantly pursuing everlasting beauty through faster, more precise, and more intuitive operation. By developing digital composite photocopiers which utilize the most advanced technology, Konica Minolta shall continue to satisfy the copying needs of customers throughout the world.